So, okay, the idea of atomic numbers. Moseley's experiment gave the idea of the atomic number. That atomic number are the more fundamental property as compared to the atomic masses. So, what was Moseley's experiment? Moseley's experiment is same as the cathode ray experiment.
Yes.
Cathode ray tube of experiment, but with a slight modification. And that electron beam is projected towards the heavy metal, right?
Yes.
So the heavy metal actually, some X-rays are emitted, and that's how the X-ray machine works. Okay, now, so basically, the frequency of the X-rays were actually the function of the atomic numbers of these heavy metals which were taken. And this gave the idea that your atomic numbers are more fundamental property than the atomic masses. Because earlier people were not aware, and now we know that atomic number really matter more, okay,
Yes.
than the atomic masses. Because atomic masses consist of neutrons and protons also. So neutron doesn't have any role in the properties, okay, because they are neutral. Atomic number is a number of protons and number of electrons. Okay? It is a number of electrons which matter. Okay. So with that we get into the modern periodic table, and which starts with the modern periodic law. Okay, and the modern periodic law is that the physical and chemical properties are the periodic function of the atomic numbers. Got it?
Yes, sir.
Okay, so I highlighted this because this is what the difference is. Got it?
Yes.
Okay. So atomic numbers, and that's how we get into the modern periodic table and the modern periodic law, right? So
Yes.
earlier, one more thing, that these there were many elements which are man-made. I told you after the uranium, after 92 atomic, okay, those elements are known as transuranic elements. Okay, transuranic means beyond uranium. Okay, trans
Okay,
means
sir.
beyond. Okay, so those are man-made elements. So those man-made elements were earlier discovered in nuclear laboratories when the Russia and USSR and America were competing each other to make more nuclear bombs. Okay, so earlier they kept the discovery of these new metals secret. Okay, at that time, in the time of Cold War, you were not born at that time, right? I remember, I was also very small, so they were not disclosing which element it was. Okay, and so it became difficult to name them, and right. So what IUPAC did, uh, until unless the name is finalized, there were some temporary names assigned to those elements. Okay, temporary names assigned to those elements, uh, whose discoveries are not confirmed earlier. Okay, earlier not confirmed, and then proper name, until a proper name is not given to them, a temporary name is assigned. Okay, by the IUPAC. Okay. So the temporary name were based on their atomic numbers, but nowadays now everything is finalized, and those Those names are not used now, okay, but and final official names are given to these elements, okay, but there are questions related to that.
Okay.
Nomenclature, the temporary nomenclature of elements with atomic number greater than 100. Got it?
Yes, sir.
Yeah. So this is given by IUPAC. So basically, there are how they are named. They are named on the basis of their atomic numbers. So Z is the atomic number. And if the atomic number is 1, and these each digit is named, okay. Okay, each digit. So first I can name the digits, okay. Then I can, for example, 0 is known as nil, okay, and 1 is known as un, right? 2 is known as bi, right? 3 is known as tri, 4 is known as quad, 5 is known as pent, 6 is known as hex. We need to give number to the digits, okay, 1, 2, 3, or 5. And the name is the atomic number, whatever the digits are there, that digits are put together, and that makes the name of the temporary name of the element, okay. 6 is hex, right?
Yes, sir.
7 is sept, oct, right?
Yes, sir.
9 is in, n, right? And 10 is 1 and 0, so no need to name it, right? So whatever the digits are there, like 1, 2, 3, okay, atomic number, if it is, if an element, right now we have elements up to 118. So suppose if you are doing on the research on the element whose atomic number is Nabila 1, 2, 3, okay, and because this element, whether it is there or not, it is not confirmed, okay. So its permanent name is not there because that element you are doing the research right now and its presence is not confirmed, right?
Yes,
So
sir.
what you try to do is you try to name it temporarily, okay, by looking at the digits, okay. So what is the first digit? 1, okay, and what I will take? Got it?
Yes, sir.
By means to try, right? For
Yes,
3,
sir.
1, 2, 3, right? And by, try, and in the last, okay, because it is a metal, you put em. Is it clear?
Yes.
Got it? Because this is a metal. That's,
U and M.
yeah, and the symbol is also derived from this initials. What is the symbol for this? U B T. Got it?
Yes, sir.
So very simple. So these are the temporary names. Is it clear?
Yes, sir.
These names were used when the permanent name, when the discovery was going on and their permanent name were not assigned. So these were the temporary names. Okay, now the confirmation is there and we have, for example, 102. Okay. So what is this? What is the name of this element? Just try it.
Nil B.
Yeah, for one, nil, nil is 0, that we all know. By is 2. You put IUM, actually you don't put two I together, so you remove one I. Okay. Nil, by M, right? So this is the element, 102nd element, and the symbol, temporary symbol, which was assigned to it was nil, UNB. Okay, got it.
Yes, sir.
But now its discovery has been established. Present name is its present day name is Nobelium. And the symbol is NO, right?
Mm.
Is it clear?
Yes, sir.
Okay, these were the earlier times when the research is going on, right? So we have the lucky number 786, right? Suppose if we find an element and what will be the IUPAC name of this element whose atomic number is 786?
Okay.
Yeah, sept, right? And this is oct, right?
Yes.
And 6 is hex, DM, right? Got it? So
Yes.
that symbol which would be assigned to it, SOH. Got it? So this
Yes.
is how they were named. Okay. Earlier, actually, there was a clash also. Some elements were simultaneously discovered by America and Russia. So Russian named it in a different way by the name of their scientist, and Americans named it in a different way by the name of their scientist. So there are stories. Okay, 104 element which was named as Rutherfordium. By Americans. And Russians name it by the name of their scientist. Okay. So, but this
Yes.
name actually later it was proved that it was first discovered by Americans. So they got the right to put the name as per their wish. Okay. So this name was later rejected. But by the time this clash was going on while they for deciding the name, the temporary name was Unnil Quantium, right?
Yes, sir.
UNQ was the temporary name given to Rutherfordium, right?
Yes, sir.
So these are some very easy, good questions and some good stories regarding the discovery of elements. Okay, some historical stories regarding the discovery of elements. Okay, and you will get one question definitely in your exams on this. Next is modern periodic table. Okay, modern periodic table, as you know. Okay, that is Now no need to have this. We have the name. Okay. This modern periodic table is based on the present day electronic configuration. Because we have the present day electronic configuration, and that is okay, that is how it is put, right? So modern periodic table, this is also known by the name of N plus L table. Why?
N plus L, because the electrons are
Yes, they are filled as per the N plus L, got it,
yes.
into various shells, subshells. Okay. So this modern periodic table has 7 horizontal rows. Known as periods. So you have elements being placed into first row, second row, third row. Okay, there are 7 horizontal rows known as 7 periods. Okay, each row starts from a filling of a new shell.
Mm.
Once you have the new shell, okay, if the new shell is starting, you will have a new period. Element will be placed in the new period. The
Mm.
period number will be it is the maximum shell number present in so whatever will be the biggest shell number. Okay, that will be the period of the element. Okay, let me write some examples. Okay, for example, if we have 6 carbon. Okay, what is the atomic number? 6. Got it. So
Yes.
how you will write 1s? You will put 2 electrons. Okay, 2s. Second shell, first shell will have just 2 electrons, and 2p. So what is the maximum value of the shell number? It is 2. Got it. Is it clear?
Mm.
So it is 2 because that is the second shell, which is the last shell, okay? The biggest shell. And this is the It is the second period element. It is the element belonging to the second period. Got it?
Yes, sir.
Let's say suppose if you have uh, sodium, what is the atomic number of sodium? If you remember,
It's 20.
23 is a mass number. Yes, 11th element. It will be very comfortable if you can go through up to 30 atomic numbers. Okay, because
Okay,
they
sir.
will be frequently used. So 1s square, 2s square, 2p6. The second shell can have 8 electrons and I have put 8 electrons. Okay, 2s. And now I have put till now 10 electrons. The 11th electron, I need the third shell. Because the maximum shell number is 3. So this belongs to the third. Got it?
Yes.
So what is the period number? Can you just quickly recap it for me?
Mm,
In how to decide in which period, which horizontal row the element need to be put.
Where there is the maximum and percent.
What is the maximum last shell, biggest shell number which is present in the electronic configuration of the metal? That will be its period number. Got it?
Yes.
I hope this is clear to you, right? Period
Yes,
number
sir.
is the maximum shell number. Okay. Then, and this whole periodic table is, it is splitted into the various blocks. Okay. And actually, the blocks the blocks are made from the vertical columns. So what are these vertical columns known as, which are running from up and down? And how many such vertical columns are there? These are horizontal rows. Got it? The vertical columns are known as groups.
Yes.
So how do you define groups? You can try first. What will
Mm,
little bit. You can give it a try and then I will explain it to you.
They are the vertical.
Yeah, actually they are the vertical. So in the periodic table, if you look, just a second, I can open it for you. The periodic table, just a second. Hmm. Okay, you can see this periodic table.
Yes,
Okay,
sir.
so you can also see there are 7 horizontal rows. Can you see them? 1 to 7.
Yes, sir.
And there are vertical columns. From hydrogen, lithium, the first vertical column that is called group 1, group 2, group 3. Okay, and what is the last group which we are having?
18.
18. So there are 18 groups. Actually, these groups were there in the Mendeleev's periodic table also. Mendeleev actually has made only 8 groups and further subdivided them to group A and B. Got it? Is it clear?
Mm, yes, sir.
So Mendeleev did that, okay. So, but later they were all splitted separately. Okay, so they were actually put into different groups. So now there also and now also we have 18 groups. Okay, groups are vertical columns. And the groups, how many groups are there? Group
18.
1, 2, 18 groups. And what these groups consist of? These group consist of the elements having same outermost electronic configuration.
Mm.
Group consists of elements having same valence shell is the outermost shell. Got it? So
Yes,
having
sir.
same valence shell, outermost shell, electronic configuration. And how many valence shell? So suppose if some element is having one electron in its outermost valence shell, other element is also having the one electron, okay, in that same shell or subshell. So they are placed one below another, okay, and they are
Yes,
placed
sir.
in the same group. So elements present in the group will show same type of chemical properties. Okay.
Okay.
So group consists of elements showing same type of chemical properties. Not exactly same or similar. More precisely, it is similar. Okay.
Mm.
Because different element will have different properties, but if the properties are very close to one another, they are actually placed in group. Okay. So
Okay.
groups consist of elements showing similar physical and chemical properties, more precisely chemical properties. Got it? So
Yes,
chemical
sir.
properties, actually why the chemical properties are same for the elements in the same group. What could be the reason?
Because of the electrons.
Yeah, because they are same outermost electronic content.
Mm.
If it is the whole atom is there, but only the out of the whole atom, only the outermost electronic electrons are interacting with the other elements while for bond formation, for chemical reactions. Got it?
Yes, sir.
Is it clear? So
Yes, sir.
outermost electronic configuration is actually the most important part, okay, that we need to think of, right? While considering the properties. Okay, all the elements in the group will have same outermost electronic configuration, and that's why they will show same chemical properties. For example, let's say group one. Which is the group one?
Um, the lead.
The leftmost group. Okay,
Mm.
hydrogen, helium, hydrogen, lithium, sodium, potassium, rubidium. Okay, cesium and francium. This is the first group which we are having. So this first group is there, and what this group is doing. So why these elements are placed in the first group? Let's say if it is hydrogen, it is 1s1. Okay, and
Yes, sir.
then you have lithium, which is the third element, 1s1, 1s2, and 2s1. Look, they have just one electron in the subshell, outermost. Don't bother about the
Mm.
inner electronic configuration. Sodium, It is the 11th element. Okay. Yes, sir. Got it? And so on.
Yes, sir.
So group 1 elements, as you can see here, will have that's why they exhibit similar chemical properties. Got it?
Yes, sir.
Very simple. Next part is, so but they are not in the same period. They are in the same group. This is the first period. This is the second period. This is the third period, fourth period, and so on. Because though they have same electronic configuration of the outermost shell, but the shell number is increasing. 1, 2, 3, 4. Got it?
Yes, sir.
So whatever the biggest shell, the outermost shell is there, that is the number of the period of these elements. Okay, so that's why they are placed one below another. So these horizontal uh, groups, they are clubbed together, they are grouped together as blocks.
Blocks.
Yeah.
Okay.
So these vertical columns grouped together. So you will see them with the same color, some same type of colors, some similar color, not exactly same.
Mm.
So the first two lines on the leftmost part, they belong to these two. Okay.
Yes,
They are S block. Got it? The
yes, sir.
whole blue portion in the middle, whole blue portion in the middle, that is D block. This one.
Mm.
And the portion on the right hand side, this whole portion, this one. Okay, that is called P block. So these vertical columns, the group of vertical columns are known as blocks. Got it?
Yes, sir.
And this lower two bands, that red and green, that is known as F block. And the reason is quite clear why this is happening. Vertical columns are grouped together as blocks, and how they're grouped depending upon the name of the subshell in which the last electron is entering.
Yes, sir.
In which the last electron. Got it? So basically, suppose these are which block of elements? So what is the last subshell? Is it S, P, D, or F? Which is having the last electron? That is S, right?
Yes.
So they all belong to S block. Okay. So these vertical columns are grouped together as blocks. These blocks have name SPDF. Okay. S block.
So what is that electrons is?
Last, no, I think I made a mistake in with the last electron. Yeah, is entering, right?
Okay.
So how you decide how you decide in which block should I place the metal? Okay, so you look at the electronic configuration, and the last electron who is entering in which subshell or the orbital, that decides the block of the electron. Got it?
Okay.
So
Yes.
these actually you can see at the last electron is entering into S. So this is S block. Got it?
Yes.
So this I hope is clear. S block. Then you have P block. Okay. In the middle you have D block. Then you have P block. Because either the electron will get into S or in P or in D or in F. Okay. Right?
Yes.
And at the bottom you have F block. S block consists of only two groups. Only two groups are there. It is because the S subshell is having just one orbital. And it can hold two electrons. Is it clear?
Yes.
D block is having five orbitals. Okay, I will make. Can you recall the name of these D orbitals? Navila, just try. Something T and followed by some algebraic something.
XY.
Yes. So
D.
DXY, DYZ, DZX, right?
Yes.
DX2 dash Y2 and DZ square, right?
Yes.
So these are the five. And each orbital can hold two electrons and they should be of opposite spins. Okay, like that. So D subshell can have 10 electrons in it. Got it. And the D orbital will the D block will have 10 columns. I hope you are getting my point.
Yes, sir.
10 columns of groups. Okay, group number 3 to 12 in D block. Why? What's the reason?
Because of the outermost.
Yeah, because the D subshell is having 5 orbitals, and so there are 10 electrons which can get into the D. Okay. So for every atomic number, subsequent atomic number, you need to change the element. Okay. So likewise, it will change 10 times. Okay. But all of them will have the electrons getting into the D. So there will be 10 columns in the D block of the periodic table. Can you see this group number 3 to 12?
Yes.
Is that clear? I hope you can see them.
Yes.
Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. Okay. These D block elements are known as, there is other name also. They are known as transition metals.
Mm.
Most of them are metals. All of them, not what are S block elements known as?
Mm.
S block group 1 elements are known as alkali metal. This is the first group. Okay, the second group of elements is known as alkaline earth metal. Alkali metal and alkaline earth metal. Okay. They both, the leftmost is alkali metal and the right, the second one, okay, is alkaline earth metal. Okay.
Yes.
Then you have D block. D block have that all the 10 columns are come get into, they are D block elements and they are known as transition metals. Okay. Then you have P block. So P subshell is having how many orbitals? Just try it. How many orbitals are there in the P subshell?
Mm. Mm.
P subshell, how many orbitals are
Mm.
there? These always the orbitals are odd. S subshell is having one orbital. Okay. D is having P is having 3. Okay. D is having 5. F is having 7 orbitals. But how many columns will be there? The columns will be decided on the basis of the electrons which they can hold. So the number of electrons will be twice. Okay.
Okay.
Okay. So P block P subshell is having 3 orbitals. What are the name of these 3 orbitals? Okay. Px, Py, and Pz. Got it?
Yes.
Is it clear?
Yes, sir.
It is Px, Py, and Pz. So there will be 3 orbitals in 3 different directions, and each one can hold 2 electrons. So total 6 electrons for 6 different elements. Okay. So there will be 6 groups in it. Okay, and the group name starts, the number starts from, so up to 12 you are having in D block, you can see from 13, 14, 15, 16, 17, and 18. So 13 to 15, six groups are there, 6 vertical columns are there because 6 electrons can come in. For every subsequent electron, I need to put the element in the next group.
Mm.
Is it clear? So
Yes.
13 and they have some different name. Mostly they are named on the basis of that whole group is named on the basis of the first element which we are having. Though some of them may have a special name. Like the first is the boron family, carbon family, nitrogen family. Nitrogen family is nitrogens, right? This is group 16 is oxygen family, oxygen sulfur, that is chalcogens, ore forming. Okay. And 17 is halogens, chlorine, chlorine, bromine, iodine, because halogens means salt forming, and noble gases, right? Helium, neon, argon, that will belong to group 18. Okay. Mainly call them as group 0, right? So each one are, so there are elements which have the similar number of p electron, they are placed one below another, and there are 6 groups. Okay, from 13 to, most of them are non-metals. Got it?
Yes, sir.
While in the D block, they are metals. Most of them are metal. They are hard. They are having high melting point. They are having catalyst. Okay, like iron, cobalt, chromium. They are used in stainless steel, right? Titanium, gold, silver, platinum. Okay, most of them are transition, and they are in the D block. Is it clear or not?
Yes, sir.
Okay. S block consists of what type of element? Alkali metal and alkaline earth metal. Just can you briefly describe some little bit, some few points about the properties of alkali and alkaline earth metal? Some properties of alkali and alkaline earth metal. From your class 10th, if you can recall. Alkali metals like sodium, potassium, they are very light, they are very soft. Okay, they can be cut with knife. So very reactive. Okay,
Yes.
is it clear or not?
Yes, sir.
Okay, so I hope this is clear to you, right? Yeah. Alkaline earth metal are bit less reactive than alkali metal, like calcium, strontium, barium. Okay, so you can see just one more time. You can have a look. Alkali metal, alkaline earth metal. I hope you can see.
Yes, sir.
Then the blue block is D block transition metals. Then you have this P block elements. The rightmost group 18 is noble gases. FCl, Bri are halogen, they are present in the salt. Group 16 oxygen family, you can name them by the first element also. And they are there in the ores, in the earth crust. For example, oxide ores are there, Fe2O3, hematite, magnetite. Got it? Sulfide ores are there. You might have studied little bit in your class 10th also. Okay, chalcogens, they are called. Got it?
Yes, sir.
So this I hope is clear to you. Got it? Next is your the lowermost part. The P block is clear. What you will
Yes.
say P block about? Just say me few words about the P block. When do you put an element in the P block?
When the non-metal will come and they
Yeah,
have like 3.
yeah, when the last electron is getting into the P subshell. Got it?
Yes.
So that is when you place the metal in P block. Okay. It is from group 13 to 18, right?
Yes.
What's the other characteristic of P block element?
They have 6 groups.
Yeah, they have 6 groups, 13 to 18.
Yes.
And most of them are
Non-metals.
non-metals. Only the black ones, Okay, you can see this black one, aluminum, gallium, indium, right?
Yes.
They are actually the metals. The gray ones, boron, silicon, germanium, the gray line which is running diagonally, that consists of metalloids which show both kind of properties.
Mm.
And all the right side of that gray line, diagonal lines, like carbon, nitrogen, oxygen, phosphorus, selenium, right, chlorine, bromine, iodine, right, and all of them are non-metals. Is it clear?
Yes.
So this I hope is clear. Got it?
Yes.
So let's move ahead. And there is one more block yet to be discussed, which is that block,
Yes.
F block. Yeah. So when the element is placed in F block, just tell me quickly.
Mm. Six.
When you have and there are, it has seven orbitals. Okay.
Seven. Okay.
So 14 electrons, 14 elements are there. They are known as inner transition series elements. Got it?
Yes, sir.
I will write it here. And they consist of two further two uh, categories, and they are the lanthanoids and actinoids.
Mm.
And where this F block is placed. So F block has that 14 elements, right?
Yes, sir.
Why 14 element? If somebody asks you, what you will say?
The rest of them.
Because why 14 elements? Why not 18? Why not 6 elements like in the P block? Because F is having 7 orbitals, right?
Yes, sir.
S was having 1, so two electrons can come in, and that's why there were two groups. D was having 5 orbitals, so 10 electrons can come in. That's why the 10 groups were there. Okay.
Yes, sir.
P is having 3 orbitals, 6 electrons can come in. Got it? Is
Yes, sir.
it? So this I hope is clear to you, right?
Yes, sir.
Okay, great. So now let's discuss some of the general properties. I hope is clear to you. Some general F block inner, they are known as inner transition series elements. That also is important.
Mm.
Let's do some questions. Let's call it as A. Let's call it as B, having atomic number 21. And so what we need to do, first we need to write their electronic configuration. Got it?
Yes.
How are we going to write their electronic configuration?
We will divide it to 8.
Yeah. And what is that? N plus L rule? One is 2s, right?
Yes.
2p6. Till now we have filled 10 electrons. 7 more need to be filled. So 3s. Got it?
Yes.
Okay. So what is the period number, group number, and block? First tell me the period.
3.
Yeah. The horizontal row in which this is being placed. Third period. Why?
Because it starts the
If you look at the electronic configuration, which is the biggest shell number?
yes, the maximum value.
It is the third shell. Okay. So it is the third period element. Got it?
Yes.
Is it clear or no? Third period element, because the biggest shell number is the third shell. Right?
Yes, sir.
So it is the third period element. I hope it is clear. Now tell me, what is the group number? For S block, it can be either 1 or 2. Okay. Then you have D block, 3 to 12. In the last, you have P block from 13 to, okay.
13 points.
Yeah, so it is basically first tell me the block, okay. That will make it easier. So which block is it?
This
S block, P block, D block, F block.
P block.
Yeah, this is a P block. So it will be either from group 13 to 18. Got it?
Yes, sir.
So P1, P2, P3, P4, P5. Okay. P1, P2, P3. So P1 is 13. Okay. P1. Because you have electrons in the P subshell. 1 electron, that is 13. 2 electrons, 14. 15. Got it?
Yes.
16. And then 17. These are the P electrons I am counting. So this is from the 17th group. Got it?
Yes, sir.
Group number 17. Is it clear or not?
Yes.
So 17th group. Now, or you can add that can tell you the group number of the P block element. Is it clear?
Yes, sir.
Let's come down to 21st element. What will be the electronic configuration? Just try.
Mm. 1s.
Then
2.
you can write it like this: 1s, 2s, 2p, right? N plus L rule. Then you can
Yes.
write it as 3s, 3p, 3d. Got it? You can write it as 4s, 4p, 4d, 4n, like that. First, you will fill 1s, then you will go back, you will intersect them diagonally, but be careful by writing them. They should be exactly written in a proper way, otherwise, while making the cut, you will make a mistake. Okay. 2s, then you go back, you start from the back, 2p and 3s. Okay, then 3p and 4s, then 3d, 4p and 5s. Got it?
Yes.
Okay, you should start from the top right hand side and go diagonally towards the bottom left hand side. Okay, in your notebook. Then go back again, come down. Is it clear or not?
Yes, sir.
Okay, so we have 1s2, 2s2, 2p6, got it. Then after 2p, I'm coming to 3s. Then what should I do, Nabila? After 3s?
4s.
No, not 4s. I should go back.
3.
3p. 3p, 6, then
4s.
yeah, now it will be 4s. 4s2. How many electron till now we have put? This is 6, 10, 10 and 8, 18, 19, 20 electrons we have put. 4s. After 4s, 3p and 4s. Now where we will go?
3d.
Yes, go back and start from again. It's come down, right? 3d. But 3d is actually inner subshell, but being placed later on, right? So 3d 1, got it? Is it clear
Yes.
or not?
Yes, sir.
Okay. So which is the block that you can clearly tell me? You know that very well.
4s.
Block number, the last electron where it has entered. Last, 4s was filled first. Look, 4s and after that 3d was filled. Got it? Because you need to go back and start over again. So which is the block number?
3.
Block is D block.
Oh.
Got it?
Yes, sir.
Great. Now, the period, which is the highest, the maximum number of shell, outermost shell in the electronic configuration, that will be the period.
4.
Hmm?
4.
Yes, fourth period. Got it. And then you have block, period, and group number. Group number D, actually, it's with you. 3 to 12. If you have just one electron, that is the start of the T. Okay. So it is third group. Got it? Is it clear or not?
Yes.
Okay. Then you have the 19th element. So just tell me what will be the electronic configuration look. And this N plus L method. Or I can write it here again. But while cutting, you need to be very careful. 2s and 2p, right? Three s and 3p, right? And 3d is also there. 3 samples. 4s, 4p, 4d, and 4f, right?
Yes, sir.
So fourth shell will have 4 subshells. That's very simple. Okay. Fifth shell will have 5 subshells. S, P, D, F, and G. Got it?
Yes, sir.
So let's try to put first where I'm going to put the electron. Let me tell me the electronic configuration.
1s,
S, 1 S 2. Got it?
yes,
S subshell can hold how many electrons? 2. Then
yes,
1s. Then I will go back down again. 2s. 2s 2. Got it. Then
2p,
how many electrons in 2p?
6,
Yes, exactly. Till now, how many electrons I have put into this? 10 electrons. 9 more yet to be put into these. With the remaining 2p. After 2p
3s,
is 3s. How many electrons?
2,
2. Okay, subshell will have just 2 electrons. Now 7 more. And after 3s, where should I go?
3p,
Yeah, 3p. Okay. So you should write it very properly, okay? A
yes,
line
sir.
should be very parallel, okay? If you just, so let's say, suppose if you make a mistake like that, okay, don't do that, okay? You will go, it will become wrong, right? Then 3p, how many electrons?
6,
No, P can have maximum 6 electrons, but we have 19 total electrons. So now,
Oh.
how many electrons need to be 10, 11, 12?
5,
12 we have already put, right, into the
Yeah.
12 and 7. Got it?
yes, sir.
No, 3p, no, 3p is 6. Yeah, you were right. Actually, yeah, not 7, that is 6. Correct. P can have 6, but we have 7 electrons yet to be filled, right? We can't put 7 to P, P can have only 6 left. So still one more electron pending. Okay. But we do not have empty 3p orbital. We need to start with a new orbital, which is that
4s,
4s1. Got it?
yes,
So now we are having 10 and 18 and 19. Got it. Clear. Okay.
yes.
So let me tell the block. What will be the block? Tell me. Block is the where in which subshell the last electron is entering. That represent the block. Okay. Is it clear? So
Yes,
which
sir.
is to which block this is belonging to?
D.
Which one?
D
S.
block.
No, S block. This is the last subshell. Got it? In which the last electron. So S block element. Got it?
Yes, sir.
So is it the group 1 or group 2? S block is having just two groups. Group 1 or group 2? That depends clearly on the S.
Oh, so 1.
S group number 1. And this belong to the class of alkali metals. At sodium potassium group, this is potassium. Okay. 19 value. Got it?
Yes, sir.
Alkali metal group 1 block you have already. Period.
Uh,
Yeah, periods are like the horizontal rows and the shell. Yeah. So where the last electron,
4.
which period?
4.
Yeah, fourth. But- So based on the block, we can predict the properties and all, right?
Yes, sir.
S block element, they are highly reactive. They can react with water, right? Okay. Now the number of elements in each first period. There are just 2 elements. Got it?
Yes, sir.
Eight elements. Eighteen elements. Third is having 8, right? Fourth and fifth. Eighteen. And sixth and seventh period. Okay. These are the number of elements.
Okay.
Is it clear?
Yes, sir.
Actually, you can add the numbers as atomic numbers. Okay. Suppose. So these were known as magic numbers. Magic numbers because after the 2 atomic numbers, the second period will start, right?
Yes, sir.
And the second period again, it will start with group 1, group 2, got it? So you
Yes,
will
sir.
see again the starting of the same repetition of properties after every period. Got it? Suppose if the second period is over, when you start with the third period, the second period is over after the atomic number 10. Got it?
Yes.
Is it clear? Why 10? Because 2 electrons and 8 electrons, 10 electrons. So the 11th element will be placed in the third period. And again you have sodium, magnesium, 12th element, that again repetition will start. Till now we have put 18 electrons. Got it. The 19th again you will start with potassium, that alkali metal S1, then S2.
Mm.
Got it? Is it
Yes.
clear? So
Yes.
actually after every, if you keep on adding the atomic numbers, after the difference of these many atomic numbers, you see a starting of each new period. Is it clear?
Yes.
And you not only see the elements starting or entering into new period, you will also see the repetition of properties. Okay. Is it clear? Suppose if the 19th element is there.
Mm.
Let's say suppose if you have sodium, 11th element.
Mm.
Where it is the 11th element. Na is there.
Mm.
In this third period. If you add 18 to it, you will get exactly below sodium in fourth period. That will be potassium. 11 plus 18 will be how much? Or not 18, actually, if you add 8 to it, okay, because the difference is 8, okay, it will be 90. Okay. Is it
Yes.
clear? The
Yes, sir.
difference you need to add. Suppose if you add further 18 to it, you will get down to 37th element plus 18. Okay, plus 18. You will get down to 37th element, which is rubidium, which is also S block element. Okay.
Yes, sir.
Is it clear?
Yes, sir.
So then you will, so after these atomic numbers, if you keep on adding them, you start with a new period and you again see the repetition of properties. That's why they are called as magic numbers. Okay. Because
Yes.
earlier people, they used to apply like a magic. Because if you add atomic number, so suppose if you are in a third period, if you want to get to the fourth period, you need to add 8 to the atomic number. You will get exactly the element which is below that element with same properties in the same group. Suppose if you are in the fourth period, okay, if you want to get an element which is just below the given element of the fourth period, that will be the element of the fifth period. Got it?
Yes.
Is it clear? That will be, so the magic number for the fourth period is 18. For the fifth period is also 18. Okay. So if you add it, you will get a new element whose atomic number is can be obtained by adding 18, and that will, the new element will exactly be placed below the given element in the periodic table. So it appeared like a magic. Okay. So that's why the magic numbers are given. So in the next class, we will be starting with the periodic properties, right? Of the
Okay.
elements. In the meantime,